So before we start, let's have first an activity. This activity is called Guess What's Next. So all you have to do is find the pattern and guess what is the next term. So let's start. So first, we have here the letters O, T, T, F, F, S, S, E, and N. So now, kindly guess what's next in the term. Okay, so the pattern here, the O means 1, the T means 2, 3, 4, 5, 6, 7, 8, and 9. So what's the next term? Okay, so 10. So the letters that next to N is letter T. Now let's proceed to the next. So we have here letter T, Q, P, H, H, O, and N. So now, kindly find the pattern and guess what's next. Okay, so the T here means triangle, the Q means quadrilateral, the P means pentagon, the first H means heptagon, the next is hexagon, the next octagon, and nonagon. So what's next to the nonagon? Okay, that's right. So the next is decagon. So the next letter will be letter D. So how about this? So we have here numbers. We have 1, 4, 9, 16, and 25. So now kindly find the pattern. So the pattern here is that they square the numbers 1 to 5. So 1 square means 1. 2 square, the answer will be 4. 3 square is 9. 4 squared is equal to 16. 5 squared is equal to 25. So how about 6 squared? Okay, that's right. So the next term will be 36. So let's proceed to the next. So we have here A, B, C, D, E, F, and G. So what's next to the alphabet? Okay, that's right. So we have here the letter H. How about the last one? So we have here R, O, Y, G, B, I. Then what's the next? Okay, so the pattern here, the Roy, G, and B means the colors of the rainbow. So what's missing? Okay, so the missing here is the color violet or the letter V. Our activity has something to do with our lesson for today, and that is sequences and series. So before we start, let's have first the learning objectives. So we have here define sequence and series. Next, graph sequence. The third one is to use summation notation to write series, and final, the sum of the series. Next, derive rules or equation from the given sequence, and the last one is that apply sequence and series in real life situation. So, for us to define what a sequence and series is, consider first this equation. Okay, so the question is, what operation should be done first to simplify the problem? Then, what sequence of operations should be done to arrive in a correct answer? Okay, so for us to get the correct answer, we should follow the GEMDAS rule. So GEMDAS means grouping symbols, exponents, multiplication, division, addition, and subtraction. So we just follow the GEMDAS rule for us to get the final answer of this equation. So let's have another situation. So we have here In your class, you are asked to observe how the plants grow from the first day to the 11th day. So as you jot down your observations, you are actually listing in the sequence, which means that the collection of data is in order so that it has the first day, second day, third day, and so on. So we can say that sequence is the collection of data is in order. Suppose that the data you want to know is the height of the plant from 4 to day 11. The data you gathered are the following. So we have here sample of data gathered. So we have here 2 centimeter, we have 4 centimeter, 6 centimeter, 8 centimeter, 10 centimeter, and we have 12 centimeter. So these data are called terms of the sequence. Now let's proceed to the next. So we have here the two types of sequence. So first we have finite sequence and the other one is the infinite sequence. So let's talk about first the finite sequence. So when we say finite sequence, it is an order of numbers that has a beginning and end. So let's have an examples. So we have here 1, 3, 2, 5, and 0. So we have here a beginning which is 1 and an ending which is 0. Next, we have here red, orange, yellow, green, blue, indigo, and violet. So our beginning here is red and the ending is violet. Now, let's proceed to infinite sequence. So when we say infinite sequence, it does have a beginning but it has no end. So let's have an example. So we have here 1, 2, 3, 4, 5, so and so forth. Next, we have here 1, 10, 100, 1,000, and 10,000, so and so forth. So when we say finite and infinite sequence, they have both a beginning, but the difference is finite sequence has an end, but the infinite sequence, it has no end. Now, let's proceed to discovering patterns. So when we discover patterns, we have the domain and the range. So when we say domain, the symbol here is a small letter n, which means it is the number of term. Now, let's proceed to range. When we say range, it has a symbol of a sub n, which means range is the nth term of the sequence. So we have here a rule, a sub n is equal to 3n minus 1. Okay, so let's have an example. So we have here the problem. The terms of the sequence from first to fifth term are 2, 5, 8, 11, and 14. So what is the pattern or general rule for the sequence? Determine the ninth term of the sequence. So we have here first the given, which is n as the 9. Okay, so n means the number of terms. So we determine the 9 terms. So that means the number of terms are 9. Then a sub n is equal to a sub 9. So now we will find the ninth term. So we have here the general rule, which is a sub n is equal to 3n minus 1. So let's now substitute the given to the given formula. Okay, so n here is 9. So we just substitute the 9 to n. So the equation now will become a sub 9 is equal to 3 times 9 minus 1. So let's now simplify 3 times 9. So we have a sub 9 is equal to 27 minus 1. Then the ninth term will be 26. Next, we have the second example. So for each sequence, describe the pattern, write the next three terms, and write the rule. So we have here 3, 8, 15, and 24. So now, let's have the A sub n. So we have here 3, 8, 15, and 24. Now we have the number of terms, which is 1, 2, 3, 4, so on and so forth. Now, let's have the pattern. So for us to get the pattern of the n term of the sequence, they just add 2 to the number of terms, then multiplied it by itself. So for example, we have here 1 times 3, 2 times 4, 3 times 5, 4 times 6. So the pattern here will be n times n plus 2. So for example, the first one, so the n here is 1, so they just add 2. So 1 plus 2 is equal to 3, then they just multiplied it by the number of terms also, which is 1. So 3 times 1 will be 3. So after getting the pattern, which is n times n plus 2, let's now proceed to the second problem, which is write the next three terms. Okay, so we have here now the pattern, which is a sub n is equal to n times n plus 2. So that is now our formula to be used. So let's have the next fifth term, which is a sub 5 is equal to 5 times 5 plus 2. Okay, so now let's simplify the equation. So 5 plus 2 is equal to 7, then multiplied it by 5 to become 35. Next, let's have the sixth term. So we have here now the equation a sub 6 is equal to 6 times 6 plus 2. So for us to simplify, let's add 6 plus 2 is equal to 8 times 6 we have, okay, so we have 48. Next, we have here the seventh term. So we have a sub 7 is equal to 7 times 7 plus 2. Now, we will simplify the equation. So 7 plus 2 is equal to 9. 9 times 7 is equal to 63. So the next three terms are 35, 48, and 63. Now, let's have another problem. So here, we have to write the first six terms of the sequence. A sub n is equal to 2n plus 5. Okay, so we will going to write the six terms of the sequence. So now, first, we get the first term. So let n as, or let the number of term as 1. So we have here a sub 1 is equal to 2 times 1 plus 5. So 2 times 1 is equal to 2, then just add 5, which become 7. Next, we are done with the first term. So let's proceed to the second term. So let us use 2 as the second term. So the equation will become a sub 2 is equal to 2 times 2 plus 5. So 2 times 2 is equal to 4 plus 5 equal to 9. Next, let's proceed to the third term. Okay, so we use now 3 as the number of terms. So the equation will become a sub 3 is equal to 2 times 3 plus 5. So 2 times 3 is equal to 6. Then add to 5, it will become 11. Now, let's proceed to the fourth term. So we use here the number 4. So we have the equation a sub 4 is equal to 2 times 4 plus 5. Then 2 times 4 is equal to 8 plus 5, it will become 13. Now, let's proceed to the fifth term. So, we have here number of term as 5. So, we have the equation a sub 5 is equal to 2 times 5 plus 5. So, 2 times 5 is equal to 10 plus 5, it is equal to 15. Now, let's proceed to the last term, which is the sixth terms. So, let number of term as 6. So, we have the equation a sub 6 is equal to 2 times 6 plus 5. So, 2 times 6 is equal to 12 plus 5. It will become 17. So, the first 6 terms of the sequence are 7, 9, 11, 13, 15, and 17. Now, let's proceed to graphing sequence. So, we have here sequence is defined only for integer values of n. Therefore, when you graph sequence, do not connect the points. So, let's have an example. So, we have here a situation which is you own a fruit stand. To make your display more attractive, you stack the apples in the shape of a square pyramid with 10 layers. Starting the top layer, there is only one apple. The second layer has 4 apples and so on. So now, write a rule for the number of apples in each layer, then graph the sequence. Now, let's do the first one, which is write a rule for the number of apples in each layer. So, let the layer as the number of terms. So, we have here 1, 2, 3, 4, 5, and so on terms. Now, we have the ninth term, which is a sub n, as the 1 and 4 apples. So, let's have the pattern. So, the pattern here will be a sub n is equal to n squared. So, they just square the number of terms. So, what do you think are the next terms for 1 and 4? Okay, so we just squared the 3, 4, and 5. So, when we squared 3, it will become 9. Then, when we squared 4, it will become 16. Then, we squared 5, it will become 25. So, we have the 9, 16, and 25 as the third to the fifth terms. So, when we square the 6, it will become 36. When we square the 7, it will become 49. When we square the 8, it will become 64. When we square the 9, it will become 81. Then when we square the 10, it will become 100. So now, let's proceed to graphing the sequence. So we have here now the layers or the 10 layers as 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. So now, let's have the graph of it. Okay, so as you can see here, below is the number of terms. Then, in this side, the 0, 5, 10, 15, 20, 25, 30, so on and so forth are the end term of the sequence. So we are done with the sequence. Now let's proceed to series. So when we say series, it says here if you add the terms in a sequence, the result in expression is a series. So it can be a finite or infinite. So series can be finite and infinite. So a sequence has finite and infinite series. Series also can be finite and infinite. So now let's have an examples. So when we have finite sequence 2, 5, 8, 11, 14, and 17, in series we have 2 plus 5 plus 8 plus 11 plus 14 plus 17. So, we just add all the finite sequence for us to get the finite series. Next, we have infinite sequence. So, infinite sequence are 2, 5, 8, 11, 14, 17, so on and so forth. So, when we have the infinite series of 8, we have 2 plus 5 plus 8 plus 11 plus 14 plus 17 and plus so and so forth. Now, let's proceed to summation notation. So, in series, we use the summation notation. So, that is summation notation. So, we have here 6 as the last value of n. Then, the 4n here is the formula for the terms. N is the index of summation. So, the index of summation can be represented by any letter, and it might not always start with 1 as the first value of n. Now, let's use the summation notation in solving series. So we have here examples. So first is the finite series. So we have here 2 plus 5 plus 8 plus 11 plus 14 and plus 17. So when we write it using the summation notation, we have here the summation of n is equal to 1 to the 6 terms is 3n minus 1. Next, we have the infinite series. We have here 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus so on and so forth. So when we write it using the summation notation, we have here the summation of n is equal to 1 to infinite 3n minus 1. Now, let's find the sum of the series that uses notation or the summation notation. So we have here summation of k is equal to 5 to 8, which is 4k. So the k is equal to 5, which means the first term will be 5 and the last term will be 8. So we have here 4 times k, which is 5. So we have 4 times 5 plus 4 times 6 plus 4 times 7 till 4 times 8. So let's simplify. So 4 times 5 is equal to 20 plus 4 times 6 is equal to 24 plus 4 times 7 is equal to 28 plus 4 times 8 is equal to 32. Now let's add it all. So we got 104 as the sum of the series. Now, let's have another example. So, we have here summation of n is equal to 2 until 4th terms, and the formula is n plus 1 is square. So, we start to 2 and end with 4. So, we have the equation 2 plus 1 is square plus 3 plus 1 is square plus 4 plus 1 is square. So, when we add 2 to 1 is equal to 3. Then when we squared it, we got 9. Then next, when we add 3 to 1, we got 4. Then when we squared it, we got 16. Then next, 4 plus 1 is equal to 5. Then square, we have 25. Now, let's simplify 9 plus 16 plus 25. Then we got 50. Okay, so now we have the other formulas. So we have here summation of n is equal to 1 until the last term is equal to the formula n times n plus 1 over 2. This is used for finding the sum of the first and consecutive positive integers. Next, we have here summation of n is equal to 1 until the last term. The formula is k squared or n times n plus 1 times 2n plus 1 over 6. And this is used for finding the sum of the squares of the first n numbers of positive integers. And the last one is summation of n is equal to 1 until the last term 1 is equal to n. Then, it is give the sum of N 1S.